Hello, today we're going to be solving equations with variables on both sides of the equation. So for example 1 here, we have lots of different stuff going on. On one side, what we're going to do is we're going to combine like terms. 3x and 7x become, or no, 3x and 4x become 7x minus 10. And on the other side of the equation, we can distribute the negative 2 to both the x and the negative 4. When we do negative 2 times negative 4, we get a positive 8. Then we can combine the like terms. So we're going to get negative 17. After you've simplified each side, what we're going to do is we're going to get the variables on one side and the numbers on the other. So we're going to go ahead and add 2x to both sides. So we're going to move the variables over. And now we're going to move the constants over to the other side. So we get 9x equals 27. We divide by 9 to get our answer then of 3. Number 2 is going to be similar. We're going to go ahead and start by distributing. We're doing 1/2 times n and 1/2 times 4. Then we combine like terms. So we get 1/2 n minus 9 equals negative 2n plus 6. We're going to go ahead and move the variables over. And at the same time, you also can start adding your numbers to the other side. The variables cancel out on one side, and all of the variables are on one side, and all of the numbers are on the other. So 2 plus 1/2 is going to be 5/2, or you can write it as 2.5. That's okay as well. So 5/2 n equals 15. Because I wrote mine as 5/2, I'm going to multiply by 2/5, which is the reciprocal. And I get n equals 30 over 5, which is 6. If you wrote 2.5n, you would divide both sides by 2.5. Okay, number 3, something interesting happens with this one. We're going to go ahead and distribute. So we get 6x minus 5 equals 6x plus 8. We're going to go ahead and subtract 6x from both sides. We get negative 5 equals 8. All of our variables have canceled out. Now when that happens, what you want to do is you want to ask yourself this question: is this statement true? Negative 5 does not equal 8. Since that is not true, this is going to be no solution. It's never going to be true. Nothing we plug in for x will ever make that true. Okay, so let's try the next one. We're going to go ahead and distribute on both sides here. You get 1/3 d plus 4/3 plus 9 equals 1/2 of 6 is 3 minus 1/2 of d plus 4. Now we do have a couple of options here. We can combine like terms, or we can go ahead at this moment and just get rid of all of the fractions. And so that's going to be what I'm showing here. My denominators here are 2 and 3. The 2 and 3 go into nicely. What I'm going to do is I'm going to multiply everything by 6. So 6 times 1/3, we're going to do 6 times 1 and put it over 3. 6 times 4/3, we're going to do 6 times 4 and put it over 3. And 6 times 9 is going to be 54. When we keep on distributing here, 6 times 3 is 18. 6 times 1/2 is going to be 6/2. And 6 times 4 is 24. At this point in time, now I can take care of all my fractions because they should reduce nicely and be whole numbers now. 6 over 3 is 2. 24 over 3 is 8. 6 over 2 is 3. And now this problem looks a little bit nicer. So at this point in time, we can go ahead and combine like terms on each side. So we're going to get 2d plus 62 equals negative 3d plus 42. We're going to add the d's so they're all on the same side. We get 5d plus 62 equals 42. And we're going to move all of the numbers to the other side. So when we do that and continue to solve, you get d equals -4. Okay, let's go ahead and try another one here. We're going to go ahead and distribute. You get 4x plus 6 equals 4x plus 6. When I move all of the x's to one side, I get 6 equals 6. And again, we have to ask ourselves, is this true? For this case, 6 equals 6. So we have no variables. We only have a statement, 6 equals 6. That's true. So when that happens, that's going to be infinitely many solutions. What that means is if I plug 1 into the original equation for x, I'm going to get a true statement. If I plug in 0, I'm going to get a true statement. If I plug in -1, everything I plug in is going to be true. So there's infinitely many solutions. You might have heard it called all real numbers. So at this point, what I'd like you to do is pause the video and try 6 and 7, and when you're done, unpause it, and you can watch the explanation. So for 6, we're going to go ahead and distribute here. We're going to do 50 times 0.5, which is 25. 50 times 2. We're going to distribute the -4 to both the x and the 2.5. We're going to find the like terms and put them together. So 25x minus 100 equals -5x minus 10. We're going to move the variables to one side and the numbers to the other. So we get 30x equals 90. We divide by 30 and we get x equals 3. 7, you start off very similarly. You're going to go ahead and distribute. You're going to do 5 times 16, which is going to give you 80. And you're going to do 8 times 1 to get 8. So it's 80 over 8d. You're going to do 5 times 24, and that is 120 over 8. And then you're going to do 6d minus 6 plus 1. So 80 divided by 8 is 10. 120 divided by 8 is 15. -6 plus 1 is -5. And so at this point in time, we can move the variables to one side and the constants to the other. Those undo each other. You get 4d equals -19. And that's okay. Sometimes you're going to get really not terribly nice answers. You can just leave it as an improper fraction in its reduced form, so as reduced as possible. So that's the idea with solving equations with variables on both sides. We're going to go ahead and try a couple word problems here. So we have Cameron paying 95 cents per song. Whenever I see something like this, per, I always think of that as a rate. So it's going to be kind of like a slope. So the new music download service charges another rate here, so it's 89 cents per song. This is again a rate. This $12 joining fee here, this is a one-time fee. So we want to know after how many downloads would the services be the same cost? In other words, when would these be equal? So for the first music service, it is 95 cents per song. So what I'm going to do is call X the number of songs. So to find his total fee, you take 95 cents and you multiply it by how many songs he has. The new one is the same idea. It's going to be 89 cents per song, but there's a $12 joining fee. So that's a one-time fee. We're going to write plus 12 at the end. So now after we've set up this equation, we can go ahead and solve it. We get 0.06x 0.06. So to answer how many downloads, they're going to be the same cost after 200 songs. So let's take another one. Here we have two taxi services. You have an initial fee. This initial fee here is going to be one time. The rate per mile, this again is a rate, so that's going to be your slopes. How many miles do you need to travel for taxi 2 to be the better deal? So looking at this, we're going to go ahead, we're going to first figure out when they're equal. So we have $2.75 as our one-time fee plus $2 per mile. So since it's per mile, we're going to call the number of miles we're traveling X. And then for the other one, we're going to do $4.50 plus $1.75 per mile. And now this is an equation we can solve. So we're going to move the 275 to the other side. And then we're going to move the 175x over. And you get 0.25x equals 1.75. You divide by 0.25 and you get x equals 7. So looking at this, right now taxi number 2 starts off higher than taxi number 1. They are going to be equal when you're driving 7 miles. So in order for taxi 2 to be the better deal, it's going to be anytime after 7 miles. Okay, we're going to try one more. We have Lenny getting $55,000 and getting annual raises. This is our rate. The $55,000 is the one time. Carl makes a one-time salary of $62,000 with annual raises of $2,000 being our rate. How many years would it take them to make the same? So we're going to write X being the number of years. And we're looking for these to be equal. So we're going to first do Lenny's salary, $55,000 plus $2,500 rate hike per year. And then Carl is $62,000 plus annual raises of $2,000 per year. And so after we set that up, we're going to go ahead and move the $55,000 over. We get 2,500x equals 7,000 plus 200 or 2,000x. We're going to subtract 2,000x. And we're going to get 500x equals 7,000. So when we divide by 500, we get x equals 14. So then to go back and answer the question, after how many years? It would be after 14 years, they would end up making the same salary. So thank you very much for listening.